Interesting lecture. So let's continue going on in here. Today we will be talking about something called DHCP, which stands for Dynamic Host Configuration Protocol. It's a protocol which provides automatically IP address. This is what it provides. Now, the way it works is an interesting phenomenon, and sometimes it can has a lot of issue as well. DHCP works with DORA, discover, offer, request, and acknowledge. And let's go in here and let's get into those stuff. This is the client. This is the server, or in this case the router. This is the DHCP. And this is the client. The client is always the first which initialize this process. Why? Because the client needs an IP address, not the router or not the server. The client says, I am looking for a DHCP server. The DHCP server says, I am a DHCP server. I need an IP address. All right, take your IP address and leave me alone. So that's how it works. Now, when a DHCP server cannot be contacted, operating system provide a temporary IP address to machines to not broadcast. This is called APIPA. APIPA stands for Automatically Private IP Address. And they are in the range of 169.254.0.0, 169.254.255.254 /16. This is what we have. So today we will make a DHCP on the router, but we also talk about VLANs as well. So let's make some interesting exercise. So first, we drag a router to the screen. We drag some switches. Okay? This is going to be a very, very long network. We can make it this way. And let's connect some computers. Okay. So as you can see, a computer network can be very complex and very weird. This one has less amount. In this case, we would like to join all the computer to some random port numbers in here. Question, does anyone remember what type of cable do we need between a switch and a router? No? What type of cable do we need between a router and a switch? That's correct. Good job. So, gigabyte 00 to gigabyte 01, gigabyte 02 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 to gigabyte 01. So, what is wrong in this picture? Oh? Is something wrong in this picture? What type of connection do we need between a switch and the router? Between two same device. What type of connection we need between same device? No? We need a crossover. As a result, this connection is bad. So we need a crossover because they are the same device. As you can see, we have a huge network. Now, let's connect the client. Does anyone know what type of cable do we need between a client and a switch? Oh, anyone? a switch, and a client. No one? Come on, guys. Come on, this is easy. Come on. We talk about cables, so it's easy.
Internet cable.
I know, thank you, but what? Crossover, fiber optic, rollover, straight. We usually have a copper straight through cable, a straight through cable. So we go, let's say, I don't know, what do you want to go? Fast Ethernet 01. This one is Fast Ethernet 02 to Fast Ethernet 0. Fast Ethernet 01, Fast Ethernet 02. This we make it Fast Ethernet 10. We want to split a bit the cables. Again, Fast Ethernet 01, Fast Ethernet 02, Fast Ethernet 10, Fast Ethernet 11. Oop. Okay, Fast Ethernet 11. Here, Fast Ethernet 1, Fast Ethernet 2, Fast Ethernet 10, Fast Ethernet 11. This is 1. Come on. 02. This is 010. And this is 011. So normally a network is full of computers. You will have a lot of computer network in any organization you will work. Usually you need to work with something called VLANs or virtual local area network. VLAN, so virtual local area network are designed to split the network into multiple segments. That's what we do in multiple segments. If the noise on the network is too high, we can split them into virtual network and we reduce it. Usually we have 2 to the power 12, which is 4096 VLAN per switch. That's what we have, 4096 VLAN per switch. That's all of them we have so far. So let's try to create some simple diagram. Let's go to fill the color, and I don't know, any color is good. Come on, why it's so weird? Okay, I'm not too sure why it goes this way. Come on. I lost the color code. Alright, so we have those guys, so let's put in here a different color. We have in here this one, and we have here this one, and here this one. Well, in here this one, we can have actually only one VLAN, but it's okay for representation. In here we can say we have VLAN 10. Okay. Here VLAN 20. Alright, and we can also build up some additional network where we can install VLAN 30, 40, etc. is up to us where we want to do it. So the guys from the bottom, they are all into 192.168.10.0/24, and this guy on the top, they are all in 20.0/24, all of them. As you can see, they are two separate networks so far. Well, we can add more network so we can have some fun. Let's add in here an additional zone, and this one we call it VLAN 30. Okay, VLAN 30. And this guy is 192.168.30.0/24, and let's add some computers in here. So basically this is the real representation of a basic network. No matter where you go, This is the most easiest type of network you can have. 03, 04, and 05. So now we need to configure the router and the DHCP clients to ensure we have what we need. So the router is the only one who can install DHCP. Okay, so let's play with the router. Enable config terminal interface gigabyte 0.0.0, which is this guy interface. Any IP address, it doesn't matter. 192.168.1.1, 255, 255, 2550, no shutdown. So we activate the interface. Now we need to create the DHCP scope. IP DHCP exclusion 192.168.10.1, 192.168.10.10. We create another exclusion 20 and another exclusion which we call it 30. Now, what is this DHCP exclusion? DHCP exclusion, it means we exclude a specific amount of IP address from the scope. Nobody can list this IP address. A good IT guy, IT person, knows that the first 10 IP addresses are leased for the routers and the last 20 IP address for the servers. Now we need to create the DHCP pool. So IP DHCP pool VLAN 10 network 192.168.10.0 255.255.0. Default router is going to be 10.1. DNS server is going to be 10.1, and we finish this one. IP DHCP pool VLAN 20, network 192.168.20.0 255 255 255.0. Default router is going to be 20.1. DNS server is going to be 20.1 as well. Exit IP DHCP pool VLAN 30, network 192.168.30.0 255 255.0. Default route is going to be 30.1 and DNS server is going to have the same IP address. So we finish with the DHCP. We have a DNS server, we have a gateway, and we have a network. Now, the problem is like this. By default, a router does not understand VLAN. So that's a problem. In order to understand, we create encapsulation.1q, which is sub interface. A router can have up to 50 sub interface per physical connection. So let's create the sub interface. Exit interface gigabyte 0.0.0.10. Hit enter. Encapsulation.1q10. IP address 10.1 255 255 255.0, no shutdown. Exit interface gigabyte 0.0.20. Encapsulation.1q20. IP address 192.168.20.1 255 255 255.0, no shut. Interface gigabyte 0.0.0.30. Encapsulation.1q30. IP address 192.168.30.1 255 255 255.0, no shutdown. So far we finished with the router. Now we need to go to the switch and create VLAN. The VLAN can be either mode access or, do I am recording? Yes. Access or trunk. In mode access, we assign a specific VLAN to a specific interface. Will trunk carry all the VLANs? What does it mean carry all the VLAN? Well, you will see very soon what I mean by that. So first, let's go to the switch 1, or whatever is this switch in here. And we have Fast Ethernet 01 and Fast Ethernet 01 and 2. Enable config terminal, interface range Fast Ethernet 01 to 2. First, let's create the VLAN. VLAN 10, VLAN 20, VLAN 30. I can name them. VLAN 10, name students. VLAN 20, name faculty. VLAN 30, name contractors. So I can do that. If I go exit, show VLAN, see, I have VLAN 10 for students, VLAN 20 for faculty, and VLAN 10 for contractors. So I can assign them specific interface so I know exactly what I want to do. Config terminal, interface range Fast Ethernet 1 to 2, switch mode access, switch access VLAN 10. So these two guys will need to access VLAN 10. We go to the next client, to the next switch, enable config terminal, and we create them again. VLAN 10, name students, VLAN 20, name faculty, VLAN 30, name contractors, and we assign them accordingly. Interface range Fast Ethernet 1 to 2, switch mode access VLAN 10. So we create those VLAN. We assign VLAN 20 to this particular guy. Exit interface range Fast Ethernet 10 and 11, 10 and 11, switch mode access VLAN 20. We go to the next one. Enable config terminal, VLAN 10, name students, VLAN 20, name faculty, VLAN 30, name contractors. We assign them again. Fast Ethernet 0, 1, and 2 is going to be VLAN 10 interface, Fast Ethernet interface range, so we can include more than one. Switch mode access VLAN 10. Exit interface range Fast Ethernet 010 to 11, switch mode access VLAN 20. We go in here, we are in this switch, enable config terminal, VLAN 10, we name it students, VLAN 20, we name it faculty, VLAN 30, we name it contractors, okay, and we exit. We assign the interface accordingly. Fast Ethernet 1 and 2 are those guys below. Interface Fast Ethernet interface range 0, 1 to 2, switch mode access VLAN 10. Exit. Interface range Fast Ethernet 010 to 11, switch mode access VLAN 20. Alright. And finally we can go to the last one as well, and we finish with these guys in here. Enable, Control Shift 6, enable config terminal, interface range Fast Ethernet 0, 1 to 2, switch mode access VLAN 10. I can do it this way too. You see, we did not create VLAN, but if we try to assign VLAN to a specific interface, it will automatically create. And later I can change the name if I want. Exit interface range Fast Ethernet 04 to 5, or whatever is this, 3, 4, 5. Interface range Fast Ethernet 03 to 5, switch mode access VLAN 30, and exit interface range Fast Ethernet 010 to 11, switch mode access VLAN 20. In here, VLAN 10, I can name it students, VLAN 20, name faculty, VLAN 30, name contractors. If I type show VLAN, you will see in here that our VLAN are active for specific interface. For example, student VLAN, it's active for Fast Ethernet 01 and 2. Faculty VLAN is for 010 and 11. Faculty contractors for this particular VLAN. Now, very interesting and very carefully to take in consideration. Basically, right now, if I go to the client and I want to take an IP address straight from the DHCP, it will fail. And we will know exactly this by looking at APIPA. So in this case, we know that if you pay attention, when a DHCP server cannot be contacted, operating system provides a temporary IP address. In this case, it shows us that there might be some issues with my DHCP. So what actually is missing is the one who carry the VLAN. So we need to assign a trunk. Without the trunk connection, we will not be able to do anything. Because the trunk carry the VLAN. So we go to the first switch, we go to the interface gigabyte 01, switch mode trunk, switch trunk allow VLAN 10, 20 and 30. We permit this VLAN to flow. We fast forward, and now if I go to my client and I click DHCP, boom, I get an IP of 10.11. I go in here, 10.12. Alright, if I go in here, I should get APIPA. Does anyone know why I will get APIPA? So the reason why is because these guys, they don't have a trunk connection. A trunk connection, it means the switches will not know who is what VLAN is what. So we go to interface gigabyte 02, which is this guy, switch mode trunk, switch trunk allow VLAN 10, 20 and 30. Let me go here, interface gigabyte 02, switch mode trunk, switch trunk allow VLAN 10, 20 and 30. Let me go to this guy in here, interface gigabyte 02, switch mode trunk, switch trunk allow VLAN 10, 20, 30. To this guy as well, interface gigabyte 02, switch mode trunk, switch trunk allow VLAN 10, 20 and 30. And that's it so far. Okay, so now if I go to this device, I get DHCP request. If I go to this one, DHCP will provide me an IP address automatically. If I go to the one on the top, it should start from 20, 20.11, 20.12, 20.13, 14, and so on. We go to every one of these guys. Okay, 16, 2017, and this is 2018. We go here, 15, 10.15, this should be 10.16. 10.17, 10.18. So as you can see, DHCP, it still provides IP address because it understands from the others about these particular networks. And even this one can get 30. All right. So you see, now something very funny. So this is 11, 12, 13, 14. So let's label so I don't forget it. So dot 11, come on, dot 12, dot 13, dot 14, dot 15, 16, 17, 18, 19, and 20. So I know this IP address. This is dot 11, dot, let's put it because they are not so small, 30.11. Come on. Okay, 30.12. This is 30.13. Here is, this one is a 20.11, 20.12, 20.13, 20.14, 20.15, 20.16, 20.17, and this is 20.18. So now, if I want to ping, I can go to the terminal and I say, I want to ping 192.168.20.11. And it should ping. But first packet is going to be lost because it takes too much time until it reply back. So let's go to simulation and let's try it again. Okay. It goes to the switch. The switch will go to the router because they are in different network. The VLAN will split the network in multiple sub-network. The router switch the packets, goes to this guy, and will go back. Now, if you pay attention, they all the time they go to the router. But, come on. But if I want to ping somebody from below, so for example, I want to ping, come on, real time. I want to ping 10.15. In this case, I will go straight to this IP address because they are in the same local network. Comparing to the trunk, these are in separate local network, local area network. Dun, 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 dun. So this is the beauty of networking. This is just a simple example of how complex a network can be. And a network can have far more than just this one, far more, far more. So this is just a way of looking at the representation of an organization, how the VLAN works, etc. So you can, the amount of possibility you can have is unlimited. You can do whatever you want to do in those. It's up just to your imagination how you want to do it. For example, all of those which you see here, you can call it only one network. Okay? You can try to connect from this router to another router, and these are in a separate network. This is in a totally separate network. Or you can go in here and make all of those two, come on, okay. So you see, all of those is just, we call it Toronto office. And we can create more than one. So this is only the Toronto office. We can create more than one. If you want to copy, you can copy this one and you connect. It's going to be Brampton office. And then you can try to connect them through different cables, fiber optic cable or whatever. The router 0. Where is it? This guy. I don't see the router. Oh, where is the router in here? Okay, it's here. So let's go in here. One. Switch a router gigabyte to router gigabyte. So you see, we can try to connect through multiple office and we can try to configure that location A can communicate with location B. So it's mind-blowing how much you can do with this one. So don't be so scared about it. This is just a simple example of how network works. I know you might be confused. You might be confused at all. Let's see what else in here we have. Networks, okay. Attendance network, okay. Subnetting. So we will be revising again subnetting because I want to give you some packet tracer about a subnetting. And in that case, we will need something called directly connection. Directly connection, it means we connect directly network A to network B. For example, let's save this one, DHCP cluster, and let's make a new one. All right. The simple way to understand a network. Dun, 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 dun. Yeah. So in here, you see, did you see the previous example? In that example, we use dynamic allocation, which is DHCP. In this case, we can use some static or manual addressing as well. We have some routers, we have some switches, so we can try to configure. However, I want to connect them with a special cable called serial DCE. Serial DCE is a serial cable which is used between the routers. But my router does not have this interface. So I can click on the router, I can zoom in, I can turn off the router, and in here I can add this additional item. Do this one. And as you can see, serial cable appear. But in here, I don't have it, so I need to do the same process. I zoom in, turn off, go in here, power on, and we finish this problem. We go serial D020 to serial 010. Now, the regular things are the same. If you want to have fiber optics or whatever, nobody can stop you. But again, you need a device which support fiber optics. We go copper base straight through, gigabyte 01, gigabyte 01. This one in here, gigabyte 00 to gigabyte 01, 001 to this guy in here. We have some clients, fast Ethernet 1. This is fast Ethernet 2. This is going to be fast Ethernet 1. This is going to be fast Ethernet 2. Okay. Fast Ethernet 1. Fast Ethernet 2. This is going to be fast Ethernet 1. And this is going to be fast Ethernet 2. So we have just a basic network. So we can say this is in downtown Toronto. And the first is going to be like this. This is going to be building A. And this is going to be building B. So we can start the documentation. I want to have a network of 10.0/24. This is going to be 20.0/24. This is going to be 30.0/24. And this is going to be 40.0/24. The first IP address is going to be the gateway. Usually the gateway is the router interface. Okay. And we can add it right in here, 30.1. And in here we have 40.1. There you go. So we have some simple understanding of this network. We can assign some computers, 192.168.10.25. This is going to be 10.50. This is going to be 20.25. And this is going to be 20.50. So we have some IP address to these clients as well. We go in here. This is going to be 30.25. This is going to be 30.50. This is going to be 40.25. And this is going to be 40.50. So we make so much networks in here. So let's configure the networks right on the spot. Enable, config terminal, interface gigabyte 0.0.0, probably is this one, IP address 192.168.10.1, as you can see in here, 255.255.0, no shutdown. We go to the other interface, interface gigabyte 0.0.1, IP address 192.168.20.1, 255.255.0, no shut. And we activate them so far. We need to go to the clients and we need to put the IP address because this is a static example. 192.168.10.25 and the gateway is 10.10.1. In here, 192.168.10.50, 255.255.0, and the gateway is still 1. By mistake I put 5, should be 50, but it doesn't make any difference. 192.168.20.25, the gateway is 20.1, okay, 20.1, and here 192.168.20.50, 20.1. Now, if I want to ping 20.25, I can ping without any problem. So you see, I can ping without any problem because both of these interfaces are connected to the router. Okay, we go in here, Alt-C, we go here, the client responds, it goes, and it goes. All right, so we finished that part. Let's go to this guy. This is the other building, and let's assign some IP address. Enable config terminal 192.160 configure terminal. Interface gigabyte 0.0.0, IP address 192.168.30.1, 255.255.0, no shutdown. Okay, interface gigabyte 0.0.1, IP address 192.168.40.1, 255.255.255.0, no shutdown. We go to the clients and we assign those IP address manually. 30.25 and the gateway is 30.1 as we put it in there. We go to this client, 192.168.30.50, 192.168.30.1. Here, same. 192.168.40.25, 192.168.40.1. And this is going to be 192.168.40.50 and it's going to be 40.1. So these guys can ping each other. If I go to PC4, I can ping any one of these. Ping 192.168.40.25 and I can ping because, come on. I can ping because they are in the same network. Now, what's left over is the connection between these two. So in here, we need a public IP address. Can anyone tell me why do we have a public IP address? No? I bored you enough? Yeah. So a public IP address is there to ensure that you can access the internet. So we need to assign an IP address to these interfaces. Interface serial 0.2.0, IP address 209.67.105, 255, 255, 255, 252. No shutdown. We go to this guy as well. Exit, interface, serial 0.1.0, IP address 209.67.106, 255, 255, 252, no shut. So both of these interfaces, now they are green. If I am on my router A and I will ping building B, I can easily ping 209.67.106 because they are directly connected. However, if my computer from here, I want to ping this guy, which is this way, will not work. So you see, it shows destination unreachable. Well, this is because the router doesn't have any information about these guys. So to fix this problem, we can try to use something called a static route. A static route is a connection which permits the user to have knowledge from router A to router B about the vicinity or the network. For example, we will go to the building A, config terminal, IP route, and we would like to reach this network 192.168.30.0. The subnet mask is this one, and we can try to use something called recursion, or next hop is this way. Recursion is the next net IP, which is going to be 209.67.106. And then I can have another example, IP route 40 network 255.255.0, and in here we can make it through the serial 021, serial 0200. In this case, we create two different static routes. If I go to my router, show interface, show VLAN, show IP route, we will see them in here. We have directly connected, 20, 30 is a static route, and 40 is a static route as well. See, 40 and 40. In here, we can use something called a default static route. So let's say IP route 00000000 through, let's say, recursion, which is going to be 209.67.105. So this is what we do. Now, because we create those, boom, as you can see, we are able to ping any one of these. We go to the router. Sorry, I pinged the wrong IP address. 30, no, that's the correct IP address. All right, we go there, it goes over, it goes here, and then it goes there. It goes here, it goes there, it goes here. So that's how you can ping any computer in the network. So that is a simple example of organization A. You can call this one in here, whatever you want to call it. Okay, this one, come on, no fill. I don't like when those no fill is not there. Let's go in here. All right, and this one in there. Location A, and this is going to be location B. So that's how they can communicate. These are two separate offices, and they connect over the internet, over through a serial cable or a gigabyte cable or whatever you want to connect them in order to have access to some resources. You get bored enough? Okay, I guess that's it enough for today. Yeah.